So you should be seeing my Chrome window. This is the computing tutorial. I just wanted to show everyone real quick how you could get to the live notes. A couple of different ways. One is on Indico. You can click on the session details. And then you can click on live notes here, or you also have a link to the actual material that we're going to discuss, which is right here. As well, there's a link to the live notes right there.
Oh, okay.
And I can show you what that looks like. Just to let everyone know, the idea is that I'm not going to be looking at the live notes, but other people that are helping to run the tutorial are going to be looking at those live notes while I'm speaking.
So talking about live note, I think this is a wrong link because I put a document that is
oh, did I put the wrong one?
It's okay. It's okay. This will be updated, but I can put it in the chat. I just want Dave's confirmation. Dave's, are you okay that I put this right now? It has a template. Yeah, okay, cool. So in here, I should see this is the anonymous question box, and you can see for each session you have a template to copy, and then the experts will answer, and this will be monitored by others. So Kirby, you can continue. And now I see people connecting, so it's okay. They all arrived into the anonymous question box. Okay, the floor is yours, Kirby, and sorry for the interruption. This is the correct link.
Sorry, I copied Kirby's into my own private area. You might want to fix that if you can for the next session. Oh,
this is one document. This is the link. Whatever people is having, we'll just put it to one document. But
for all sessions, have one document.
Yeah. All of the sessions are into the first page of the document gets this. So perhaps Kirby, as you share perhaps you click on the link that I just sent on the chat, and it has the sessions, different sessions on the. Yep, here it is. So the different sessions are written in a table of content, and then the template is what you copy paste with all of the horizontal bars. You can write your questions where it is written on top, and then the expert names will write their name, will answer. And once you're satisfied with the question, you can see on the drop-down menu that there are different ratings, I would say. In greens, you will see I got it. Kirby, can you click on the not answered yet drop-down menu? So then you're, yeah. So you have partial answer. If you're still confused, feel free to say it because it's important. And then once it's crystal clear, you can put I got it, so that it will really help people to know when they are all good with the questions. And remember that all questions are no question is stupid. And by asking your question, you will help others for sure.
So we're going to use this one that's called question box through the whole time then? Is that what you're saying, Claire?
Yeah, I think it would be simpler this way, and then it's only one to update everywhere. So bookmark this link. This is your question box for everyone, and I want to interrupt further. So thank you, Kirby, for this.
Sure. No problem.
So we need to relink this one to the main Indico.
Sure. And my bad, I just did it quite late.
Okay. I did for myself.
Yeah, Tom, why don't you do that? So everybody put your questions in the one that's in the chat.
Great. Okay. So that's an important mechanism to get your questions documented, especially if you want, if it's something that is looking for a very detailed technical answer, such as, wait, what command do I type, so that we can have an archive of that. If you have a conceptual question, you can either put it there, or you can actually raise your hand and stop the tutorial at any time. We're totally cool with interruptions. As you can see, we just we go with the flow. So please feel free to raise your hand, ask questions if you want clarification on anything whatsoever during the time. So I'm going to be talking to you about storage spaces. What are some of the questions that we want to answer? We're thinking about what are the types and roles of DUNE data volumes. And when I say a data volume, I mean a place where we can put files, data, things like that, store them there with different types of access capabilities, and also different levels of services from those volumes, and also different capacities. We want to make sure that you can understand what are the commands and the tools to get data into those storage volumes, out of those storage volumes, move them around, things like that. And the overall objective is to help you try and understand what the different data volumes are, what their properties are, and then which are the right ones to use at the right time. And there are a couple of ways to do that. One is being able to display the volume information, such as the total size of the volume, how much is available, where it is mounted on, or where it might not be mounted if it isn't directly accessible on the computer that you're using. So again, so that you can understand how to make use of all those data volumes in an appropriate way. And one thing that is important is we want to make sure and emphasize the difference between commands that are used to handle data on storage volumes that are grid accessible versus the way that you would interact with a storage volume on an interactive node. For those of you that may not be familiar, the idea of grid access, we have distributed computers all over the world that DUNE has access to through a large amount of infrastructure, either through the Open Science Grid or some of the infrastructure from the worldwide LHC computing grid. Your home area at Fermilab or at CERN is not accessible to those computers that are distributed all over the world. So you can't use the same tools to change a bash script that you have on your home area on an interactive node as you would use to bring in a file or a copy of file or stream in a file on a grid node that happens to be located 5,000 miles away from where you are sitting, or from the computer that you're logged into, or the storage volume where your data is kept. So that's the overall idea of what we want to talk about here at storage volumes. And we start with this so that it's kind of foundational, the idea of where data is stored and how you get access to that data, because it really is important to have that in mind as you start doing more and more work on both interactive nodes and also on distributed computing around the world. So in general, for an introduction, there are three types of storage volumes that you're going to encounter at Fermilab. They are local hard drives, network attached storage, and large scale distributed storage. Each of them have their own advantages and limitations. Knowing which one to use is not at all straightforward or obvious. And so it is important when you start to think about, oh, okay, this is the task that I want to accomplish right now, which is the right storage volume for me to use in order to most efficiently and quickly accomplish my goal. So with a little bit of understanding, a little bit of foresight, you can definitely avoid some of the common pitfalls. Most importantly, you can make sure that whatever you are doing is efficient, fast, and doesn't cause interruptions in service for yourself or other users. There are a couple of little bit of vocabulary that I want to go over. One of them is POSIX. This is a term that not everybody is going to be familiar with, but it's an important thing to kind of think about. POSIX access is explicitly the portable operating system interface. There's a Wikipedia article that's listed there. And it allows users to directly read, write, and modify using standard commands. So an example, using bash scripts or using fopen. In general, POSIX volumes and POSIX access is for volumes that are mounted directly into the operating system. So if you have a laptop, it contains a hard drive, and the way that you interact with it in general is through a POSIX interface that allows you to read, write, move files around at will. And it doesn't matter if you are on the Wi-Fi or you're not, you have direct access to that hard drive. And there are some volumes that we'll talk about that have both POSIX interfaces, but also are network attached at the same time. But then there are other volumes that don't have POSIX access. So you can't do just any type of activity that you want on that volume. And there's a limited set of activities and commands that you can issue. Another thing we talk about is grid accessible. So there are storage volumes that are distributed around the world, and they are accessible from grid nodes. from on the Open Science Grid, the WLCG as well, but they require very specific tools and suites of tools to handle data being stored there and getting access in and out. In general, grid access to such a volume is not POSIX access. It's a very limited set of commands that you can issue. And we'll get into that a little bit more, but I kind of want to set the stage for the idea that we have storage elements that could be hard drives or tape drives, and we can get to them across the network, but we have to use a very specific set of tools in order to access them. Another thing that's interesting to think about is the idea of a file that is immutable. This is a concept that you want to think about when you are accessing these distributed storage volumes that are grid accessible. The idea is that once you write a file to one of those volumes, it can actually be modified. You can read it, you can move it or delete it, but in general, you can't actively modify it the way that you might actively modify a Word document or a Keynote document that you have saved on your laptop. If you wanted to modify it, what you would have to do is you would have to read it off of one of these grid accessible volumes, modify it locally on your laptop or on an interactive node, delete it from the storage volume, and then copy it back in the same place. In general, it's a pretty big hassle, and it's not a good choice for any files that you really want to change often to do something like that. So at this point, we're actually going to get into some of the details. I'm going to make this a little bit bigger. So I mentioned that we're going to go over kind of 3 different types of storage volumes: interactive storage volumes, network attached store, and then grid accessible. The first 2 are actually located on the interactive volumes. So you have already, in the preparation for this session, you have already logged into either some Fermilab interactive nodes, maybe DUNE GPVM, pick a random number between 1 and 16, should have logged into. And just to let you know, this is something that took me a long time to realize. The GPVM stands for General Purpose Virtual Machine. So at Fermilab, we have these general purpose virtual machines set up as interactive nodes for all of the different experiments. So there's ones for DUNE, NOVA, Microboon, UDE, you name it. All of those experiments have their own general purpose virtual machines. And when you log in, you end up in the shell located in the home area. And it is very similar to a user's local hard drive, but interestingly enough, it is actually network mount. So these home areas are centrally managed at Fermilab. And the access speed to that volume is very high, and it does have a full POSIX access. But the thing to remember is that they are in fact network volumes, which means that in order to read data on and off of them, they go across an Ethernet cable. This means that they are not safe to store certificates or tickets on them. It's an important thing. In general, you're going to need a Kerberos ticket or maybe a grid certificate to submit grid jobs. All of the infrastructure is already set up with defaults to store those certificates or tickets that you generate on an interactive node in the appropriate place. I'll get into that in a little bit, but you don't ever want to copy any of those things into your home area for a number of reasons. One of them is also you have a single home area at Fermilab, and it is used for all of the experiments. So if you put anything into your home area on a DUNE GPVM, and you happen to also be a member of a different experiment, for me, that's Microboon. If I log into a Microboon GPVM, whatever I have generated on a DUNE interactive node stays in that home area and shows up on a Microboon interactive node. This is both good and bad. If you start to set up defaults and you forget about them for login defaults, environment settings, and you have set up to be in a DUNE environment, but you log into the Microboon and you have forgotten about that, suddenly the software may not work the way that you want it to. So it's a good thing to remember. Should mention that this area is not accessible from grid worker nodes. You really shouldn't use it for code development, mostly because it just doesn't have enough size. You've really only got about 2 gigabytes of access there. You should use it for initialization scripts, for small files, that you need in that home area, but potentially because you want to use some aliases or things like that across multiple experiments. I should say at Fermilab, you need a valid Kerberos ticket in order to access the files in your home area, which means if you cannot access your home area, if you get a strange message that says, unable to read the area, one of the things you may want to do is you may want to log out and log back in and update your Kerberos ticket that's cached on the interactive node. An important thing is there are periodic snapshots are taken. So if you delete something, you actually can go and find it within the snapshot, depending on how recently it was deleted or modified. And the area that you want to look at for that is the /NAS home, network attached storage home /.snapshot, and then go inside of there, and you should be able to look at past versions of your home area. Next type of storage volume I wanted to talk about was locally mounted volumes. So these are physical disks mounted directly on the computer, so that GPVM, it's physically inside the same node. And so you're not accessing it across the network. It's mounted through the motherboard, as I said, not over the network, and it's used as temporary storage for infrastructure services, so /var/temp. And in general, the main reason that it is there is for the operating system to have an area that is independent of any kind of networking. But in general, for us as users, we can use it to store our certificates and our tickets. As I said before, they're saved there automatically with owner read permissions only and everything else disabled. Well, I guess actually you can write to them, but they are very small and really shouldn't be used to store any data files or for code development. Files in these volumes are not backed up. It is just to let you know that those things are there. And so if you are doing any development or looking to generate a grid proxy with a specific attribute, that's where it's going to end up. But otherwise, it's really not all that useful for anything other than holding on to certificates and tickets. The last volume that we want to talk about that's mounted on the interactive storage volumes, and you can access it with POSIX, is the network attached storage element. And these behave very similarly to a locally mounted volume. At the same time, the way that I would suggest that you think about them is that they function very similar to services such as Dropbox or OneDrive. So these are volumes such as DUNE app or DUNE data, those directory areas. They are mounted on all of the different interactive nodes, but they are going across the network. It is fast and stable POSIX access. But it is a limited number of computers and servers. It is not accessible on the larger grid computing. And in general, you don't have those grid tools to access them either on FermiGrid, the Open Science Grid, or the WLCG. There are two important things to think about. One is that DUNE app, where you really should kind of utilize that as where you do your code development, does have periodic snapshots, and they're located in this area right here. But DUNE data and DUNE data 2 do not have any snapshots or backup. There's a difference between the two of them. DUNE app, you don't have as large of as a quota. This is in general because the system is designed for being used for code development, so it has a little bit faster read and write capability. But in order to improve that, the quota has to be decreased. So you're going to be a little bit limited on how much you can store on that volume. Whereas DUNE data, it's opened up a little bit, and I'll get into the actual numbers of that later on. So the last thing that we want to talk about are grid accessible storage volumes. At Fermilab, we use an instance of Dcache and NStore for our large scale distributed storage. And in general, Dcache and NStore combined have a capacity for more than 100 petabytes of storage and something on the order of tens of thousands of connections coming in. The idea is that we want to be able to put all of our raw reconstructed data, all of our derived data sets into Dcache and NStore as appropriate, and then have that distributed computing out on the open science grid or the WLCG access all of that data in order to run algorithms and processing on the data that is stored there. So this is a very robust and high capacity service. But at the same time, it means that we have to limit the way that the data is accessed in order to maintain the robustness of the service. We just kind of can't mount it on every single grid node everywhere in the world. As much as we would love to do that, that would be fantastic, but that would mean that the entire system would be so brittle and fragile that it would fall over pretty much instantaneously. And what is more important than having access everywhere mounted is having a stable and reliable resource that we can use to store our raw data, to store the output of our production processing, and then allow analyzers to access all of that information. And specifically, the way that you want to access them whenever possible is you want to access them over xrootd. This is talked about in the next session. And I'll go over the details of what's going on there. There are mount points on the interactive node, but they are both slow and unstable. And so we highly recommend that you avoid that at all costs. There are 4 different types of Dcache volumes. And I guess I should explain a little bit. The idea is that with Dcache, what we have is a huge number of hard drives that have been kind of merged together to appear as one consistent volume. So instead of seeing 1,000 different hard drives on 1,000 different mount points, Dcache takes the function of taking all of those hard drives, making them appear as just one volume, and then serving them all out. At the same time, NStore is doing the same thing, except with tape volumes. So this is actually magnetic tape. Those of you that are old like me might remember cassette tapes from the 80s and the early 90s. It's basically the same idea, except it is packaged slightly differently. But the idea is that we have a much higher capacity to store all of our raw data and our production, and we can use that to increase how much data we can store, and that's how we can get 100 petabytes of storage for all of the data that DUNE is going to take. There are 3 different types of Dcache that are disk. There is the persistent Dcache, scratch Dcache, and resilient Dcache. I want to focus mostly on persistent and scratch. As you might guess from the name, persistent Dcache, the idea is that the data that is written to this volume is actively available for reads at any time and will not be removed. It will be persistent on that volume until it is manually deleted by a user. The great thing is that you can write a file to persistent Dcache using the grid accessible tools, and the file will stay there until it is deleted. This is different than scratch Dcache, which I'll go into. And the idea is that with scratch Dcache, it is a large volume and it's shared across all of the intensity frontier experiments at Fermilab. And when a new file is written into scratch space, an old file has to be removed in order to make room for the new file. Removal is based upon a least recently utilized policy. So whatever file has been read the least recently, that file is going to get deleted until there's enough space for this new file that is being written to the volume. So if you write a file to scratch Dcache and you don't read it or use it for 45 days, chances are it will have been deleted and will no longer be available. That's different than persistent, where the persistent Dcache, if you write a file, it will stay there forever until it is manually deleted. The downside of persistent Dcache is that it has a limited volume. It is not as big as scratch space. Ken has raised his hand to correct me, and I'm happy to hear a correction.
Just to amplify that, you mentioned 45 days. That is not a minimum guarantee. There's actually no minimum lifetime guarantee in Scratch.
Yep.
So it might last that long. It might only last a week. Just it depends
That's
how
right.
busy things are.
Yep.
The 45 days is the resilient thing. Those will get deleted after 45 days if you don't touch them.
Yep. And Ken makes a very good point here that this was just an example. As he said, it could be as little as a week. It could be as little as 48 hours. If an experiment or an analyzer starts a workflow that is misbehaving and they write petabytes of data back to the Scratch space, then they can actually flush out everything else that every other user is producing, and that can cause some very serious problems. If you managed to, right before Neutrino 2022, write 600 terabytes of data back to the Scratch space, and you flushed out all of Nova's final fits and all of their results going into their oscillation measurements, you probably would not have an enjoyable day. And you would have to answer to a lot of people to explain why that had happened. At the same time, writing to Scratchbase is actually really great because you know that when your file comes off of a grid worker node, it will have a place to land, and then you will have a little bit of time to look at it, review it, make sure that everything works correctly. If you were to write to persistent Dcache, persistent can actually fill up, and once it does fill up, because nothing goes away until it's manually deleted by a user, you actually won't be able to write anything else. So in general, it is our suggestion that if you have an output coming from a grid worker node, that you should write to the Scratch base first, evaluate the files, and then if you know that they are good, transfer them either to persistent or to tapeback Dcache. Ken.
Yeah. One point is that not only you can't write, nobody can write. And 300 people will be mad at you.
Yes. Ken.
Wow, and perfect segue into what I was going to say, which was mostly that. Also, we have seen cases where if you have a bunch of jobs trying to write to persistent and they're full, that can actually, because it keeps retrying, right? You can actually grind all of Dcache to a halt. And then not only is it 300 people, it's many times that because you can affect multiple experiments. So don't do that.
Yeah.
And actually in the future, and Steve can correct me if I'm wrong, in the future for writing outputs of grid jobs, you will only be able to write to Scratch at some point.
Right. And also in the future, individual quotas are going to be persistent within the next year or so.
Yes.
Yeah, that will help with the.
That's right.
The whole thing shouldn't fill up then. That's
correct. So the last style of Dcache volume I wanted to talk about is a tapeback Dcache. This is a little bit more complicated. The idea is that we have a conglomeration of disks that are acting as a storage space, a cache space in front of the NSTOR tape library. So if you write a file into this area, it goes onto a disk at first, but then it is mirrored onto permanent storage on NSTOR on a tape. The interesting thing is that it is a cache in front of the tape library. So when a file is written into this area, if there is not space available on the disk, then a file will get removed from the disk. That file will already be on tape and will be permanently stored on tape. So it won't be deleted forever, but it will no longer be immediately readable. The new file will be written to disk and then copied onto tape. So it's a two-step process. But it also means that files are not available immediately to be read on disk. They actually need to be staged from tape first, because that cache has a limited size. It's not actually the size of the entire tape library. And we'll see if this works. Let's watch a video of a tape robot. So just to let you know, this is what a tape library looks like on the inside. And there is, in fact, a little robot that runs around and grabs a physical tape, pulls it out of its slot in the library, and then puts it into a drive so that it can be read. And the files on that tape can then be written into the disk cache that you would then read into your grid job or anything like that. It's really cool. It's fun to watch. I've seen it a couple of times in person. It's not bad. So we have a table here that is a summary of storage spaces. One of the questions that I saw in the chat was, what are the quotas? So for persistent Dcache right now, there is no quota, but in a year, hopefully we will have quotas. There is about 100 terabytes per experiment. It is not tape backed. Scratch, again, there is no limit on the space, but at the same time, if you write something, it will flush something out. The retention lifetime for Scratch, it varies. It's approximately 30 days, but there is absolutely no guarantee, okay? There's resilient Dcache. I'm gonna skip over that because we're phasing that out. But then talk about tape back Dcache. So there isn't a quota there. The space is on the order of 10 petabytes. The cache in front of it is, again, a least recently utilized eviction. It is the only one that is tape back. So the idea is that it has permanent storage, and that's where we archive both our raw data, our production, or if you had precious n-tuples that were your dissertation, at some point it would be very good to put them into tape backed Dcache so that they were stored in a very stable and a very long-lasting archive situation. Note that all of the Dcache volumes are grid accessible. That is not the case for either your home area, the app volumes, or the data volumes. So on the, I think I got this a little bit wrong. So the data volume is in total 32 and then 30 terabytes. Those may have been updated. I apologize, but that's on the order. And then the app volume is about 15 terabytes. And these are the areas that you can locate them. There's a really nice diagram right here that actually shows how things are associated with them. Right now, there is not a per user quota on persistent Dcache, but that is going to be updated within the year, hopefully. And our plan is that what we are going to do is we are eventually going to phase in that quota. And those that are using more than the quota, their data won't be deleted, but they also won't be able to write anything new. So until they get back below the quota, they will basically just have a read-only volume. And we haven't established what that quota size is yet because we plan on expanding our persistent volume, hopefully in the next year, and then it will be determined to be a not oversubscribed amount of data. So in general, in this diagram, we have experiment GPVM, so general purpose virtual machine. For you, it's going to be DUNE. We have things like the temp area, the var area that are mounted locally, but then we have things like the network attached storage, your home area, your app volume, data. Those come over the network. There is also CVMFS, which I haven't talked about, but others will discuss, that is mounted there. And And then you have Dcache over here. And again, the way that you want to interact with that is either through xroot D, reading it in, or through ifdh. The persistent and the scratch areas, those are just disk only. Tape backed actually gets you access to the NStore tape library. And if you've got a grid worker node over here, you notice that the grid worker node has no access to the app or data volumes or the home area. It can only have access to Dcache or CVMFS and potentially other RSEs. So I'll pause for a second before we start to get into both monitoring commands and tools. I think there were questions in the chat, but those have been answered. Any other questions? I'm also going to take a sip of tea. Okay. Seeing them,
maybe we could do a poll. Could people raise their little hands if they have successfully logged in? You don't have to raise your hand or not raise your hand.
$15, 16, 17, 18.
They're busy logging in and raising their hands.
It's not
Yeah,
easy.
it looks pretty good. Looks pretty good.
Well, that's great. Okay.
Okay, if you're having trouble logging in, well, we can probably help you over in the chat or on even better on the Google Doc, because part of this is debugging how you log in.
And let me just add something. As soon as your question is answered, please do not forget to update the drop-down menu so that it guides experts to know which questions are not answered yet. Thank you so much.
Okay, so people can take their hands down unless they want to keep them up. Thanks.
Yep. So to emphasize something real quick, please remember these volumes are not infinite. It may seem like a petabyte of storage is in fact more data than you're ever going to produce. But that in general is not as far outside of the realm of possibility as you might expect, especially if you happen to make some unfortunate mistakes and don't debug your workflow properly. There are, in fact, consequences that will impact your own computing operations, but also impact other people on DUNE and other people on other experiments. So monitoring your and the experiment usage of these volumes is important for smooth access to the data and simulation samples. Specifically, Ken pointed out that if you fill up the persistent area and it causes Dcache to grind down to a halt, if you basically do a denial of service attack, an unintentional denial of service attack on Dcache, and none of the experiments at Fermilab can access any of their data, that would be really unfortunate. I've got a link here to the persistent access. Oh, and I'm happy that you're not going to be able to see my password, but you do need a Fermilab services login to access this volume. But as you can see right now, our persistent, we have 350 terabytes of used space, but we have only allocated 377 terabytes. So right now we are sitting at 93% full. And we can go down here and we can look to see who is using the most amount of data. Right now it only lists the top 4, but if you go a little bit further down, and if I am scrolling in the right place, and we click on current, now we can see who's using the most. So, and yeah.
Actually, it's current that, yeah. Oh, people are being pretty good.
Yep. So if you look,
Yeah, it's not sorted, is it? Or it's sorted alphabetically, I should say. It's not sorted by usage.
yeah.
There's one hand raised.
What's a
Sungbin, did you have a question?
Sungbin? Did you have a question or?
No, I forgot to
Oh,
raise
okay.
the hand answer. Yeah.
No worries. That's great. That is the
Sorry.
easiest question for me to answer. So I do welcome questions. Please ask them, but that's even better. Okay. So I'm going to go ahead and leave that site. The total volume, we have a program called Rusio that is actually managing our storage elements around the world. And there is a link to that that I'll let you explore on your own. But since we're running out of time, I want to get to the commands and tools. The idea is we want to show you some examples to display some of the storage information and access data. So hopefully everyone is logged in to an interactive node. In Bash, you have this command that is a df, which is disk free. That's what I've always referred to it as. And we use the -h for human readable format. And it's going to list the information about each of the volumes that are mounted. And the exercise that I've got for you is from the output of that command to see if you can identify your home area, the network attached storage spaces, and then the different Dcache volumes that are mounted. So I'm going to go find my terminal and bring it over if I can. But I'm going to give you guys a little bit of time to do that as well. Mostly because I need to log out of the Microboon computer that I was logged into. Okay, so I'm going to change to a different screen share. So I'm logged into DUNE GPVM 08. By the way, this splash screen actually does have some useful information into it. One is the very important notice to users about the fact that that's a federal computer and that you need to be utilizing it for authorized activities only. But also at the same time, it will give you some information. There's the host name, the operating system. So this is Scientific Linux Fermilab 7.9. Tell you what the kernel is, how much memory is available, how many cores on this node. So this is a 4-core node. The architecture, the number of people that have SSH logins, and then also the load average right over here, which right now the load average is 18. And given that there are 4 cores, that is unfortunate. And there are some things that are happening on this node that we might consider taking a look at. But if I look at the output
Did everybody log into GPVM 01? No, yeah, oh dear. Okay, yes, okay.
Note to self, there are 16 computers. So
15.
Sorry?
15.
15.
15, yeah.
Sorry, 15. So pick a number between 1 through 15 and not always 01.
Well, one is
That's
actually
08.
special. It's got a few extra mounts that the managers need, so don't all jump on that one because other people need to log into it too.
We do have the page that tells you the load on all the machines. And so maybe we should put a link to that in the documentation.
Sure.
Okay.
So to just give you some idea, the first all of these volumes that you hear right here, that you see right here are kind of the local mounted volumes. So /var, /temp, /op, scratch, things like that. These are all a physical disk that's located within that node. If you look later on, you will see names such as these right here. So these are network attached storage. So DUNE app, DUNE data 2, DUNE data, and then some other utility volumes that I would think about it as if you see a sign that says authorized person only, if you don't know that you're authorized, then you are not authorized. So if you see these other volumes over here and you're asking yourself, should I be using those volumes? If you have to ask that question, then no. But then we also have some other volumes such as these PNFS volumes down here. So these are the Dcache areas. In general, we don't want to access them trying to use POSIX tools. We'll show you some other things, but those are the general volumes that are mounted on this interactive. And the next exercise is going to tell you how to access those PNFS, those Dcache volumes. But I want to stop for just a second and let folks ask questions if they want. Okay. We'll go back to storage spaces. Okay. So as I mentioned, the Dcache volumes, we don't want to access them or try to attempt to access them through the POSIX commands, ls, cp, mv, those kinds of things. Instead, there are very specific data handling commands that have been developed that are all part of the ifdh, Intensity Frontier Data Handling Client. And in general, this is the best way to access any of the Dcache volumes or any of the other remote storage volumes that DUNE has access to. So it's a tool suite that facilitates selecting the appropriate data transfer method from the many possibilities while protecting the shared resource from overload. You may see ifdh-c, C stands for client, but otherwise it is the Intensity Frontier Data Handling. I have an example of how to copy a file. In general, hopefully you've all completed the mission setup, but if you haven't, then you can go back and do that. But this is the set of commands right here that I'm going to go through. The first one is to set up the environment. The next one sets up the specific version of the DUNE software. KX509 generates a certificate. From that certificate, we are going to set up an analysis role, generate a proxy, and then at that point, we are ready to do the data handling command that will copy files around and move them in a grid accessible way. So I'm gonna go ahead and switch over real quick to my terminal so that you can see what's going on when I do these commands. I'll just do them one by one. And if you want to follow along at home, please go ahead and do that. So first thing I've done is I've sourced that bash script, the DUNE pre-setup. It has a version of the software inside of it. So then
Kirby, you might want to make certain that your screen, oh, maybe you can't, it's hard. I guess it's okay. It's just sometimes the bottom of the screen turns out to be invisible if people have stuff on their computers. Okay, I can see it now. Okay, good. Okay. I can't help you if you've put your Zoom client in a strange place. Sorry. But, so I've set up the DUNE software. I'm going to issue the KX509 command. Generates a certificate for me. I would like to be in the analysis role. So I'm going to issue that. And then I want to generate a grid proxy. And it lets me know that it's going to be valid for 120 hours. So I've got until Tuesday, May 17th. I already had a proxy that was generated. So now the one thing, and I realize I have forgotten to do this because we have changed, I need to set up the ifdh client, the Intensity Frontier Data Handling client. So I then issue that command. And then I can do something like this. Quick question.
Does everybody know what /dev/null is? Or should I ask, can someone tell me what dev null is? Raise your hand if you know the answer to that question. Tom, you don't count. Doug, you're the cat. Someone who isn't an instructor. I guess Doug is not an instructor. Doug,
I'm
you were
not an
taking this
instructor.
tutorial. I apologize. Doug,
So I
please
have
let me know.
I have two questions based on this tutorial.
Yeah.
I joined a little late, so I didn't see the contents of DUNE setup. Could you cat that? But to answer your question, right? Dev null, I have another question, even what you're on the screen, but dev null is basically memory. It's a way to, it's like the bit bucket. When you want to write something to nothing on a computer, you write it to dev null.
That's correct. It basically pours it out the window.
My question is the length of the proxy important? So you've done a VOMS proxy init.
Yeah.
It has another switch that allows you to take and get a larger proxy length.
Yeah.
Are there cases with our storage where that is an issue? Specifically, I mean, do we have any storage that will not accept the default length?
I don't know of any. I'm going to stall here for a moment while
we run with a very long. We run with a very long proxy in our glidins, 4 days long, and nobody is.
No. It's actually the size. If you do a VOMS proxy info minus all, it tells you the size of the proxy. My question is about proxy size: 1024 bits versus 248.
Okay.
496.
We never had any problems up till now. And we usually take the default.
Okay.
Yep. So as Doug has nicely answered, dev null is basically the bit bucket. It's the trash can. So I have just copied 593.7 megabytes per second off of dcache and into the bit bucket. The nice thing is that ifdh allows me to do a lot of commands like this. I can do, so this is the copy command because I put CP there, but if I put ls there, or if I put move, in general, just copy and then delete is what I would do, is the mechanism that I would do. But you can ifdh CP or RM or ls, do all of those things. You can get full details in the link. But in general, that is the best way to access any of the storage volumes that are dcache or tape based. Any questions? Also, I'm going to change my share real quick back to here. Okay, so the second exercise, using ifdh command, if you can try and complete the following tasks. So make a directory in your dcache scratch area called DUNE tutorial May 2022. Specifically, what you can do is you can do ifdh space mkdir space and then the directory name, and it'll do that for you. If you had followed the setup, you would have a myfirstlogin.txt file in that directory, to that directory, and then also copy it from your scratch directory into dev null, and then finally remove that directory using ifdh rm directory. Note, you actually need to have that directory empty when you delete it. And another thing to note, if your destination of a CP command is a directory instead of a full file name with the full path, you need to add the -d option right after CP so that it can copy it over. And now is when we probably start to get a lot of questions, but So I'm going to give you guys a couple of minutes to do that, play around, and hopefully not overload Dcache. The nice thing is all of these tools should allow you to do all of these commands without any real concern for that. And then going back, I'm going to switch back to my terminal. Doug, you were curious the contents of this script.
Dune pre-setup.
Yep. All it does is it exported an environment variable for a specific version of the software, and then aliased Dune setup to be this.
Thanks.
Sure. So right now we're working on exercise 2 and ifdh commands. Just give a thumbs up or raise it thumbs up if you finish going through all of these tasks, or if you've completed everything, or raise your hand if you've got a question. And we'll give it maybe 3.
I just put up the node busy link in the chat for those who want to see why the machine they're on, it's not working so good. 04 and 08 are not good places to be.
Yeah, so I believe, Zachary, you have a question, ifdh command not found on Dune GPVM11. So I forgot in these instructions, after you've done the bumps proxy init, you need to do setup space ifdhc and then enter. So that command right there.
Dune setup doesn't do that for you?
No, it does not.
That's bad.
Which was news to me, but that's okay.
I got that to the live document so we remember for next.
Yep. No problem.
I can
Thank
make an
you,
argument
Zachary,
that
for
it shouldn't,
asking.
but yeah, we should write down what it does and doesn't do.
Yeah.
And yeah, actually, I would argue by default it shouldn't, probably. At least not the one in the common family repo, but
Also,
that's getting a little in the weeds there.
if you don't have a proxy ifdh, we'll try to make one for you. It will not always do what you want to do, which is why we put it this way.
Yeah, it's a good point, Steve, especially on the validity length. The default is much shorter.
So the question in the chat is the ls command will not show my_first_login.txt file. I believe that it would still be in your app user area. Eventually you will have deleted the DUNE tutorial May 2022 directory. So yeah, no, it would not be there. But it should still be in your app user area. So we've got some hands raised. Stefano?
No, yes, thumbs up. I don't know if it's here or in another place was to say that I have
Okay.
ended the exercise.
Okay, great. Wishy has a question about when I copy a file from the scratch area to dev null. Yeah. So should I add in front the, yes, you should. And in fact, actually, the next thing that we're gonna discuss is how you construct the exroot D URI.
So I've actually a question. By mistake, I didn't use ifdh to create the directory. Is this a problem or?
Technically, no, it is not. In general, no, it's not a problem. We would encourage you not to use the direct commands to make directories or list directories, to instead to use the ifdh commands to do so, because it's using a better protocol that is more stable and more robust and won't cause problems. But if you did happen to make a directory with just the bare operating system mkdir command, if there were no errors when it was created, then it will be fine. If that makes sense.
Okay. Thanks.
Sure. Let me go ahead and keep going. As one of the, although I guess, Sergio, are folks raising their hands for questions or saying that they're done?
I think because you mentioned we should raise the hand when we are finished.
Yes, okay.
In my case, that's
Yeah, we should maybe do the thumbs up at that point. Sorry, I
Yeah,
used the
thumbs
wrong
up.
notation.
But that's okay. Okay, yeah, let me go ahead and keep going. So one of the questions in the chat was about the basically putting this information right here in front of the file name. One of the things that you may notice is that this is a relatively complicated directory structure. If you're on an interactive node, you're not actually going to see it at all. But what it is doing is it is telling ifdh, but also exroot D, what server it should talk to in order to look for a specific file or a directory. So exroot D to tell you it is the extended root daemon, and it's a software framework designed for accessing data from various architectures and in a completely scalable way, both in size and in performance. So this is how we allow having tens of thousands of connections to one disk server spread out all over the world, is by going through exroot D. There is a link to the man pages, but in general, we hope that we're going to give enough examples of the commands that you won't necessarily need to dig into that unless you have a very specific use case that's starting to get a little bit more complicated. If we look at the commands that I've listed here, exroot D will do a lot of things for you. It will do ls, it will do copy commands, things like that. But what we want to try and understand is how we can do a translation between an NFS path and an exroot D URI. Because right now we have something such as this right here, which is a PNFS match. And it, yeah, so this is the network attached storage mount point, which in general is a little bit different than the structure for the URI that I listed earlier. But the thing that you can notice is if you basically take this PNFS off, right? And instead add this right here, you will get exactly the same thing. But if you want to do the xrd commands, you need to parse it apart. So if you want to do an ls command, you use xrd file system, tell it what server, then you tell it what command you want, and then where it's going to happen. So I can do this real quick. And because we did actually just delete this area, I think you are correct, Priya. You're going to get nothing visible. So if I do the same thing, yeah, path not found. But if instead I just do my user area, now you can see the directories that are in my username. So, and I just stopped my sharing as opposed to switching. But the nice thing is that once you have that xrd URI, or you've done a listing of all of those areas to find out what's in there, then you can actually just plug in that xrd URI, which looks a little bit like a web page, but is in fact, you know, that xrd specific format. So you could run a larsoft command, which you'll learn about later, saying that I want you to stream in the data from this URI, this location on Dcache, and then I want you to process it with this input.fickle. Within your code, you can actually do a T file open and put in an xrd URI, or in Python, you can do a root file open and then give that. And as long as you have a network connection, it will reach out across the network, connect to the Dcache server, and then start to stream that file in a stable, scalable, and high-performant manner. So we have another practice exercise, which I'm actually going to let you guys do at your leisure. Oh, wow. That, Jan, that is a fun and fantastic error, and I don't know why you would be getting that error. But
sorry for that.
No, that's interesting. There's something interesting in your environment, and so
maybe.
We'll need to debug that a little bit later.
Yeah, okay.
But as I've gone for an hour as opposed to 45 minutes, I think I'm going to stop real quick and ask if there are any final questions, or think of them while I talk about the key points. Things to remember: your home directories are centrally managed, and they're meant to store setup scripts or I never edit this, setup scripts. And they are mounted on all of the different experiment nodes. So if you're a member of Nova and DUNE or SBND, the same home area is going to be everywhere. So please don't put anything automatically set up that is specific to DUNE. And I will edit this. You absolutely should not put certificates there. Anything that is mounted across the network should not have a certificate or a proxy. Excuse me, should not have a certificate or a ticket in it, a Kerberos ticket. Network attached storage, like DUNE app, is primarily for code development. DUNE data and DUNE data 2 is for n tuples and small data sets. Dcache volumes, tape, resilient, scratch, offer large storage with various retention lifetimes that you need to understand before you put the data there. And they need to be accessed using ifdh and xrd for the data that's located on Dcache, so that you get scalable and performant access. So, any questions before I edit this to remove certificates from everything?
Yeah, I just have a point for people. One thing, if you've logged out and logged back in again, you're going to need to rerun the DUNE setup. There's certain things you have to do once, and there's other things you have to do multiple times. And if you log out, you don't have to remake all the directories in the setup, but you do need to run DUNE setup every time you log in. If you're only on DUNE, you could make that part of your profile, but if you're on 2 experiments, you can't do that either.
Okay, I'm going to hand things over to Steve.